Hello, everyone. Welcome to the e-learning space of data science for public policy. This video is brought to you by the DSPS Data Science and Policy Studies program under the Chinese University of Hong Kong. This video is supported by the CUHK Courseware Development Grant Scheme. Our topic for this video is about basic data visualization using R. First of all, you'll have to download two software, which is R and RStudio. RStudio is a user-friendly interface for you to type R codes and to execute. So you will need both the two software installed in your computer. So here you can refer to the link or just Google their software and download, and they're both free. So you can look for the free version and set it up. And after the installation, then you open RStudio and you'll enter an interface like this, where you have several blank windows, the white windows here. And then we're going to use this to execute R codes. And the data set we are using for today is a data set that is based on the average height and weight of American women. So the one that is modified can be downloaded from the DSPS e-learning space below this video. So after you download that dataset, you save it somewhere in your local computer, such as in C drive, D drive, or on your desktop. Then we're going to load the dataset by typing read.csv here. So first of all, here we have the console, which is where the codes later are executed and give you the results. And first of all, we have to click on the top left corner, this button, and then we have to add an R script. So you can see here, this is the R script. So it's untitled one, so you can rename it later and you can save it. So this is where you write your codes and you save your codes. And the console down here is where R execute your codes and give you the results. So first of all, after you downloaded the dataset, you save it somewhere. For example, for me, it's going to save in D drive. So first you have to type read.csv, and then a bracket, and then a quotation mark to indicate your path. So note that when you type a quotation mark, then the text inside is going to turn green. So it is just a reminder that R reminds you that this is going to be a text for them to read. So you first type D drive and then dataset.csv. So your path may not be the same, because if you save it in desktop or in somewhere else, then your path is going to be different. So don't forget to assign it a name. So we type something like an arrow to assign a name, for example, women, because this dataset is based on the average height and weight of American women. So after you load it, and then it becomes some blue ticks appear, but nothing happened because right now we just assign it into the name of women. So if you type women here, you can see the whole data set coming up. So we only have 15 rows and a few columns. And at the same time, you can also type it in console. So the difference is that when you type in console, such as women, it also appears the same thing, but when you save your script, it's not going to appear. So if you want to double check a lot of things, you can type it in the console. Or if you want to save your codes or whatever you type, you can type it in your script. So it's up to you. And so just now we have a look at the women data set. We can see there's name, height, weight, and then we have some age and their BMI, body fat. So first of all, we can make use of the summary function. So we type summary women, which is our data set, and then we can see they have a more overall view on each column's quantile. For example, in height, we can see the minimum and the maximum value. And then in district, here at the right, we can see district here. We can see there is four girls living in downtown, 3 girls living in village, etc. So here is an overall view, especially useful when your data set is too long to read every single row. And an alternative would be if you're interested in a particular value, such as the maximum of height in this data set, then you can type women and then a $sign, which is indicating the next thing is the column. So women $height means you're only looking at the height column and you're looking for the maximum value. So, and then it's going to print out the maximum value directly. So similarly, if you want to know the minimum, say weight, then you can also type the similar codes and then you can get the minimum value of weight. And sometimes if you have too many columns, then your summary would look quite messy, a lot of information to read. So you can also look at particular quantile of one column, such as you type women age, and then you can have the quantiles of age from minimum, maximum, and then the median, and then the first and the third quantile. So next thing, you can see whenever we have to mention, whenever we want to look for a column, we always have to type women and then the $sign. So when you're only working with one data set, unnecessarily, it is going to be some kind of redundant work. So we can also type attach women. So this code means we are now attaching the dataset into as the default. So whenever you type height, and then it's going to print out all the height data. So you don't have to put women $sign anymore. But note is that if you have two or more data sets, then it's not useful to use attach because you are going to mix up the data from different data sets. So right now we are only working in one data set, so it's fine to use attach. And then we can also, now let's start plotting. So first we have to type a plot function. So usually a function is like this. So you have the plot or attach or summary and then a bracket. And inside the bracket, you indicate what you're doing. So here, plot, since we attach women, so we don't have to type women $sign anymore. So for example, we want to know height against weight. Then we can plot and execute. Yes, and when you run, you can type Control Enter, Control R. It depends on your computer default setting, and you can also change the settings from here. I think it's from keyboard shortcut, or you can type run. So it's up to you. So each line, for example, after you type plot, you type run, and then you are going to have a plot like this. So here we can see height against weight. So the first one is the y variable and the second one is the x variable. And then here we can see all the dots lining up. So we can see as somebody who is taller, then generally their weight is also large. They also have a higher weight. So when we want to fit a line and indicate their relationship, although right now we see this is pretty obvious that there is a linear relationship, but if we want an extra fitted line under it, then we have to first type, fit a linear model. So we assign a name called model, and then we can type LM. LM refers to linear model, and then we can do the same thing, height against weight, and indicate the data set, which is women. And then we can have a model, and then we can type summary model and see what happens. So right now we can see a bunch of numbers. So basically they're telling you that we fitted the model and then the residuals looks like this, and then we have a coefficient. So the coefficients here refers to the y equals to mx plus c. So remember, in line 16 right now I type a sharp. So sharp means this line of code is not going to be executed. So this is for you to type your own note or your reminder. So a linear model has a form of y equals to mx plus c. And right now we can see down the console we have the coefficient, and the coefficient tells you that c equals to the intercept. So which is 0.664. And the weight, that is the slope. Slope equals to m equals to 0.01625. So this is where you read your slope and your intercept. So this is where you can construct your linear model in the form of y equals to mx plus c. And don't worry too much about it because you are going to learn it later. And then, okay, going back here, And then we can try to do a plot that has the fitted line. So other than just type height and weight, why don't we do something more than this default plot? For example, we might want to add a title. Then we type main equals to a title. So right now I'm not going to create a special title for it, but you will know how to modify the text here. And then we can indicate the type of the plot. Right now, let's put P for now. Later, I'll explain why we are doing this. And then we can add a subtitle. And then we are going to do, for example, we can change the name down here, XLab, which is X-axis label. Let's not do just a weight. We can also indicate this is in kilogram. And then we can add a YLab, which is the Y label. So instead of height, we can also change it to height with a unit. So after that, you can see there's something popped up. First of all, there is a big title up here, and then we have a subtitle down there, and then we have changed the height and weight into the text that we want, that is including the unit. So here, it's pretty simple. For example, I want the title to be height and weight plot. And then I execute it again, I click run. And then now the title is changed. So this is where you can modify your title and your XLab and everything. So let's come back. And how about the model, the fitted line? So just now, remember, we fitted the model, the linear model, and then we get the numbers. So what do? So we type appline. Appline means we can add an extra line onto the plot, and then we type model. So the line comes from model. And let's change the color. So COL is the color equals to red. So note that whenever we type the settings, most of the time we have to add a quotation mark. So here we can see now we added a red straight line. And this red straight line is coming from this summary model, the linear model y equals to mx plus c with intercept equals to this and slope equals to this. So this red line is exactly what the model we fitted, the numbers, gives us. So this is how we fit, for example, a plot with two variable. And how do we know how to type or sub or XLab? So here on the right hand side, not just the plot. Of course, the plot you can choose to export it, or you can also screen capture your plot. And on the right hand side, aside from the plots, we can also make use of the help window. So help window here. First of all, you can search it here. So we search the plot function. And then you can see this is a generic XY plotting, and then they have the description and everything. So here, basically, it tells you that what arguments you can type is all the arguments here. Here we have Y against X, so height is the Y, weight is the X. And then after that, we can, for example, indicate the type. See, we indicate the type P. P is the default, so it's the points. But say, if we want to change the type into, say, use L, lines. So we change L here, and then we run it. And then you can see now the plot becomes a line that is connecting all the dots. But if we add appline here, the appline, remember, it's a straight line because we fitted a linear model. So this tells you that there is some deviation along between weight equals to 60 to 65. So coming back to help window, and then aside from changing the plot type, we can also look for example, main equals to title, sub equals to subtitle, and XLab, YLab. And then you can also do furthermore different kinds of things. And there are examples. For example, they show you how to plot extra stuff. For example, indicating LWD, and then or adding extra points. So it's up to you. And you can also use the second search. So this is fine within the topic. So after you go to the plot page here in XY generic plotting, then for example, we can type type, and then you can directly go to arguments type. So you can know what type you can choose to change your plot style. And then when we come back to here, so here, this is pretty obvious that even if you just look at the points, you know this linear, and you add an extra linear line to show the fitted values. But what if we have a plot, let's plot rank against height. So rank from the summary of women, so the rank is just some random number generated. So it is just a created column. So don't worry too much about why there is a rank column. So if you plot the two variables, so here you can see the dots are scattered everywhere. So of course because rank is a randomly generated number, so of course the dots are going to be very randomly scattered in your plot. But if you still insist to add an appline, so you can still also do linear model, rank against height, data equals to women, color equals to red. So here in line 14, we assigned the name as model to this linear model. But here, if you're too lazy to assign an extra name, you can also directly type what stands for model. So now your model becomes a linear model of rank against height. You can directly type this here to replace the model, to replace this acronym here. And then you also indicate color equals to red. So you can see now we have a very flat line at the middle because the deviation, so the dots are very bipolar. So they're somewhere very at the top and some are very located at the very bottom. So you're going to have an appline that is located somewhere in between. But whether it's useful or not, you have to think about it. So I type some think about whether you need this appline. So this is so basically this is just teaching you how to add line, but how to effectively tell the story of your data and to visualize it in a concise way, that is something extra to learn beyond just coding. Okay, so the next thing we're going to learn about is histogram. So histogram is it's always for one variable. So what to do? We first type hist. So hist means histogram, and then we type the column that we are interested in, for example, age. And then let's see how that goes. So we have a histogram of age, but sometimes you may think that the bars are a bit, so here we have a total of four bars, or 5 bars with 1 empty. And sometimes you may want to have more bars to look at, so you can type bricks, and then you will have a more precise histogram. So here the bricks are a bit it's breaking the data points a bit more frequently, so you can have more bars showing more detailed information. And say you can see there is some at the very right end, there is somehow we can say it as an outlier. So if you want to drop the very right end, that data, so you don't only want to keep for example, you only want to keep the data points that is located between age equals to 20 to 26, then what you do is that you first again type histogram, and then you indicate the column age that you are interested in. You also keep breaks equals to 10, and then we can type x limit. This means that the range of x-axis that you're interested in, and then we can type equals to c. C means a vector of 20 to 26. And then we can also choose a color. So instead of red, let's try salmon color. And then now, first of all, you can see the color changed. And then here we can see the x-axis is only looking at 20 to 26 compared to the previous one. We're also looking at 30, which is, if we consider that as an outlier, we want to drop it, then we can make use of the xlim function to only focus on the x-axis that we're interested in. So this is the end of today's visualization practice, and I hope you enjoy. So here again, you can export, or you can save the image, or you can also use the screen capture tool in your local computer to cut the image out. And here, don't forget, after you do all the stuff, and when you close the RStudio, the console is going to be gone. So if you want to save your work, first of all, you have to click save here, saving your R script. And then you can try to name it, put a name and then save it. So thank you, and I hope you enjoyed this practice.